Alright, I had this idea of adding a computer opponent. Right now, this Pong game is where we left it, ignoring the multiple ball thing. Now it has player on the left moving with W and S, and player on the right moving with up and down. But what if we wanted to have one of those human controlled and one of those computer controlled, like probably most games are? Let's say we'll first of all make it perfect. It's often easier to make it perfect, unless you're talking about chess or something, than to make it beatable. So let's say I'm going to keep the one on the right, and the one on the left is going to say self.y equals ball.y. That means it's always going to move unnecessarily a lot of the time, and it's never going to miss. So right now, the one on the left is the computer following the ball. Maybe it's a little bit off because the y coordinate of the rectangle is the top and the y coordinate of the ball is the middle. So maybe sometimes we should make it go a little higher in order to hit the ball in the middle instead of barely graze it on the top, but it's still doing it. And the problem with this is that you would never lose. Usually, even if you have a hard mode in a game, you still want it to be beatable. So we want to make the computer do the wrong thing some percentage of the time. And how could we do that? Well, we could make it try to emulate humans, like it could watch a bunch of human players and do what they do. But let's try to find something similar or simpler. So we could add a bit of randomness where some percentage of the time it'll just go the wrong way, inexplicably, unpredictably. Or we could add some rule where, oh, maybe it gets tricked when the ball bounces, it keeps going the wrong way for a second, has to turn around, like there's a sort of inertia to it. Or maybe it doesn't move until the ball's already moving across the screen toward it, like it moves after the ball passes a certain threshold, and if it's too far on the other side, like a tennis player in one corner when the ball's going to the other corner, then maybe it won't catch up in time. So how could we do that? I don't really see a way with this current system because of the y just getting plus or minus. We'd have to do a calculation every frame and say, okay, is the ball higher or lower? And is the ball in a certain spot? I would rather have a little system of velocity, just like the ball has a velocity and it sort of moves, quote unquote, on its own. We could give the paddle a velocity and then let that do its thing. So let's imagine we apply that to both. It's getting to the point where we could split this into a subclass or something, but let's keep it with the same class for the moment. Let's give it a Vx. Nah, we don't even need a Vx, right? Because it never moves horizontally. Let's give it a Vy and go from there. So now I'm going to say Vy is our new way of moving the human one. So Vy is negative and y. Vy is positive, and then something at the very end of this will be applying it. So let's try this without even changing the left one. Just make sure this correctly works with the human on. It is working, as far as I can tell, the same. Maybe, no, it does have one difference, which is that it keeps going. I forgot to turn it off. If you stop moving, if you stop pushing the button, then it keeps flying off in that direction. So we need to add something with what happens if you stop. How about that? I'm not really an if, elif, else guy, so I type that pretty rarely, but I think it works here. And now it's working just as before. If you push up, it goes up. Push down, it goes down. If you push neither, it stops. So now we can use the velocity as a little setting for our computer guy. And you could say something like, if ball.y greater than self.y, then the velocity is positive. And this means it'll move in that direction. And we could try it for the other one. And maybe to test it, we could make it slow, like only move one or something, so that it might fail and not get anywhere, or not get far enough. Let's try that. Let's say it is perfect, it's always moving in the right direction, but it's slow, so that it might not catch the ball in time. Let's see what happens if we hit run there. Oh, yeah, it's doing it. Wait, I put the wrong value on one of these. Well, that should be it. Less than and greater than are always the hardest things in the world, right? You have to switch them to be opposite of what they are. And when you have less than, greater than, negative, positive, or, and, not, it's so easy to go the wrong way and say, well, I meant to do a double negative, but I did a triple negative. So this is pretty good. It's got the ball always followed by the paddle, but the paddle's slow enough that sometimes it doesn't catch up. Let's try 2 and see how that looks. Yeah, that's pretty. It's still bad enough that it'll lose a good percentage of the time. I wonder if we make it 3, then it would never lose. I guess we could calculate like how long does it take the ball to get from one side to the other, and then how long does it take the paddle to get up here. Well, since the screen is wider than it is tall, then it'll always have more time going horizontally than it will vertically if they're the same speed. So if this Vy is equal to the ball's Vy, then the paddle will never lose, right? If the paddle starts at the very bottom and the ball is headed toward the very top, then it'll get there in time. So we can't make this 3, because then the computer will be unbeatable again. And we could make it unbeatable with a lot simpler code. So why did we go to all the trouble of writing these lines? Right now, the paddle can lose like it just did if it's all the way at the bottom and the ball's headed toward the top, or it's all the way at the top and the ball's headed toward the bottom. So honestly, I think that's pretty good. If you play as a human, you might win a certain percentage of the time against this bot, and you might lose if you do something dumb. Maybe we could add some tricks where it once we get the different angles going, where the ball bounces a little more horizontally from the middle and it bounces a little more steep from the edge of the paddle, we could add some tricks where the AI opponent will move a little farther than it has to in order to hit the edge when you think it won't, or something like that. or maybe that would happen naturally, and we don't even have to tell it to. Then it would add some trickiness and make it interesting again, because I don't know if you've ever heard of like I don't know if you've ever talked about game design or in psychology rewards, but we want things to be unpredictable. If we win every time and get the same result every time, it's no fun. If we lose every time and get the same result every time, it's no fun. But if it's in the middle and it's unpredictable, then people are drawn in, to gambling or to unreliable things are often more addicting because they have that spice to them. So we want our games to be easy sometimes, hard sometimes, and that's how it goes.